In this video I'm looking at the solution to question 4 of the June 2011 Edexcel FP1 paper. The topic of the question is numerical solution of equations. The question starts then by giving us a function f of x equal to x squared plus 5 over 2x minus 3x minus 1. And in the first part of the question asks us to differentiate to find f dashed x. We're then told that the root of the equation f of x equal to 0 lies in the interval 0.7 to 0.9, and we're asked to take 0.8 as a first approximation to the root alpha and use Newton-Raphson process once to obtain a second approximation and give the answer to 3 decimal place accuracy. The first of the question then asks us to differentiate, so just writing f of x first of all as x squared plus 5 over 2x to the power minus 1 minus 3x minus 1 gives us that f dashed x is equal to 2x minus 5 over 2 x to the power negative 2 minus 3. The marking here was a method mark for getting at least 2 of the values correct in the derivative, and then finally an A mark for getting it fully correct. In part B of the question we're asked to use Newton-Raphson process. Now you can look this up, but it will tell us that an approximation x1 will come from x0, the first approximation, minus f of x0 divided by f dashed of x0. So we need to take our value x0 of 0.8 and calculate f of 0.8 and f dashed of 0.8. So that's just a case of substituting the values 0.8 into the function. So for f of 0.8 we get 0.8 squared plus 5 over 2 multiplied by 0.8 minus 3 multiplied by 0.8 minus 1. And that turns out to be 73 over 200, or you could give it as a decimal, 0.365. F dashed of 0.8, well again just substituting the value into the derivative, so it's 2 multiplied by 0.8 minus 5 over 2 multiplied by 1 over 0.8 squared, then minus 3. That evaluates to be negative 849 over 160, or as a decimal, negative 5.30625. Alpha, our second approximation to alpha, so second approx to alpha, which is going to be x1, our value of x1, is equal to 0.8 minus f of 0.8, which is, we've calculated to be 0.365, and divided by f dashed, which is negative 5.30625. This turns out to be 0.86878, etc., or giving it to 3 decimal places as we're asked to, 0.869 to 3 decimal places. The marking here was a B mark for any correct expression for f of 0.8. Didn't necessarily need to be evaluated. A method mark, again for attempting to substitute 0.8 into f dashed of x. A method mark for a correct substitution or into a correct expression for Newton-Raphson, and then finally an A mark for the answer 0.869. Well, that's the end of the solution to that question. Solutions to other questions from this module and other modules can be found at www.furthermaths.org.uk.